Hi, welcome to our channel of IGNOU Audiobooks, Indira Gandhi National Open University, School of Computer and Information Sciences, SOCIS, Certificate in Mobile Application Development, CMAD. BCS 091 Introduction to Mobile Architecture. Block-2 Mobile Operating Systems. Unit-5 Basics of Android. 5.0 Introduction. An Android is one of the most widely used mobile operating system that supports variety of smartphones and tablet computers. Initially, Android was developed by the Android Inc., which Google bought in 2005. In 2007, Google released the first beta version of the Android Software Development Kit (SDK), whereas the first public version, Android 1.0, was announced in September 2008. Android source code is available under free and open source licenses. For mobile devices, Android provides a unified approach to application development that means mobile developers develop apps only for Android, and their applications should be able to run on different devices. Powered by Android, it is a standalone software base that can be deployed easily on any type of hardware configurations. Features of Android. Android is a robust operating system that challenges Apple 4GS and supports good number of features. Table 5.1 lists some of the features of Android. Features description. Interface quite simple and attractive user interface. Database SQLite, lightweight RDBMS, relational database. Management system. Multi-touch is available, 2 or more objects can be touched. Multitasking, 2 or more applications can be run at the same time. Multimedia support H.264, H.263, AUMR, MPEG-4 sulfur monophosphide, AUMR WB, AAC, HEAAC, AAC 5.1, MP3, WAV, MIDI, JPEG, PNG, BMP and GIF. Connectivity Bluetooth, Wi-Fi, LTE, NFC, GSM, Edge, IDEN, CDMA, EVDO, UMTS, and WiMAX. Adjustable widgets. User can adjust widgets to show and hide contents, can resize them. Messaging service SMS, short messaging service, MMS, multimedia messaging service, and GCM, Google Cloud Messaging. Internet browser Chrome, Firefox with support for HTML5 and CSS3. 5.1 OBJECTIVES. After going through this unit, you should be able to know the features of Android OS. Understand interface. Using a virtual keyword. With the help of Bluetooth or USB, we can link up keyboards, portable speakers, pen drives, etc. with our mobile phones. The reaction to any information is intended to be brisk and gives a liquid touch interface, regularly through the vibration feature of the gadget to give reply to the user. To react to extra user activities inbuilt. Equipment, for example, accelerometers, gyrators and proximity sensors are utilized. For instance, altering the screen from portrait to landscape or empower the user to direct a vehicle in a racing game by pivoting the gadget, recreating control of a steering wheel. Home screen is the underlying root on any Android devices, which is like the desktop found on PCs. Android home screens are made out of application symbols and widgets. App icons are used to start the relevant app, whereas widgets are used to display the live auto-updating content such as a weather forecast, the user's email inbox, news, widgets, etc. On top of the mobile home screen there is a status bar that shows information about the Android phone and its network. Status bar can be pulled down to uncover a warning region where applications show critical data or updates. You can drag any application onto the home screen and recent screen. Lets users to switch between recently used apps. Figure 5.1 shows some of the interfaces of Android OS. Look at the screen. 5.3 APPLICATIONS. Applications, which are commonly known as apps, expand the functionality of the device and are written using the Android Software Development Kit (SDK) and, often, the Java programming language. The SDK bundled with a set of development tools like debugger, programming libraries, a handset, emulator, documentation, instructional exercises and test code. Android has turned into a developing determination of third-party applications, which can be acquired by downloading and installing the APK, Android application, package, file, or by downloading them with the help of an application store, which assists users to install, update, and remove applications from their gadgets. Google Play Store is the most ordinarily known application store, introduced on Android phones that consent to Google's similarity prerequisites, and enables users to peruse, download and update applications which are made accessible by Google and other third-party app developers. Open nature of Android allows various third-party application stores likewise accessible for Android, either to give an alternate for gadgets which are not pre-stacked with Google Play Store and applications that can't be offered on Google Play Store because of policy infringement or because of different reasons. Amazon, App Store, GetJar, and SlideMe are some of the commonly known third-party app stores. Now let's learn to develop a Hello World app. First of all, you have to download and install the Android Studio from https://developer.com/studio/index.html. Start your Android Studio and then in the Welcome window, click on Start a new Android project as shown in Figure 5.2. Look at the screen. Figure 5.2, Android Studio. Figure 5.3, Configuring New Project in Android Studio. In the New Project window, enter application name as Hello World as shown in Figure 5.3. You can also change the location of your project, but don't select any other option. Now, click Next. In the next window titled Target Android Devices, go with default values in. Then click Next as shown in Figure 5.4. Look at the screen. Figure 5.4, selecting the target Android devices. After clicking Next in Target Android Devices, requested components shall be installed as shown in Figure 5.5. Click Next. Figure 5.5, Installation of requested components. In the next step, i.e. add an activity to mobile, click on Empty Activity Thumbnail and then click Next as depicted in Figure 5.6. Figure 5.6, Adding an activity to mobile. In the next step, i.e. customize the activity, go with the default values or can give activity name and click Finish as shown in Figure 5.7. Figure 5.7, Customizing the activities in Android Studio. After processing, Android Studio will start the IDE, Integrated Development Environment, as shown in Figure 5.8 which builds the project information. Look at the screen. Figure 5.8, Building the project information. The code that was generated for the project is shown in Figure 5.9. Figure 5.9, Hello World application. Now from the left navigation tree view, go to App greater than Res greater than Layout greater than Activity _ My First App.xml as shown in Figure 5.10. Figure 5.10, Palette in Android Studio. Now from Palette, drag the text view element onto the layout as shown in Figure 5.11. Figure 5.11, Text view in Palette. The following are the steps to set up your device. Basics of Android. Associate your phone to your PC with a USB link. In case you're dealing with Windows, you have to introduce the USB drivers. Now, you have to enable USB debugging mode. Tap to Settings greater than Developer Options. In Android 4.2 and newer versions, by default developer option is hidden. 2. Make it visible, go to Settings, About Phone, tap Build number 7 times. Now, go back to the previous screen to find developer options. The following are steps to start app. Tap the app module given in the project window and after that click Run greater than Run, or select Run from the toolbar. From the Select Deployment Target screen, pick your device, and afterwards click OK. Now app will get installed on your device and afterwards it gets started automatically. Table 5.2 lists some important files that are essential to run the app. Table 5.2, Important files to run an app in Android. Files description. App greater than Java greater than com. Example, hello, world greater than main activity, Java. This is the primary point for your app. After build, when you run your app, the system initializes an instance of the current activity, which loads its layout. App greater than res greater than layout greater than activity underscore main.xml. This XML, extensible markup language, document characterizes the design for the UI movements, which contains a text view component with the content, hello world. App greater than manifests greater than Android manifest.xml. This file depicts the essential elements of the application and furthermore characterizes each of its segments. Gradle scripts greater than build. Gradle you see two files, i.e. one file for the project and one file for the app module. Every module has its own build Gradle file, but here you will find only one build Gradle file, but this project has just one module. Most of the time, you'll work with the modules build Gradle file to configure the development of your app. 5.4 Memory management. Memory management includes managing RAM, random access memory, by moving processes back and forth between primary memory and hard disk at the time of execution of the program. It keeps an eye on each and every place of the memory, regardless of either it is granted to process or it is free to use. It verifies the amount of memory is to be granted to processes and also decides which process will obtain memory at what time. It keeps trail whenever some memory gets released or unallocated, and accordingly it updates the status. Android memory. Android is derived from a Linux-based OS with 2.6 X kernel, which is capable enough to handle most tasks and very well mannered as it is deployed on native open source C libraries that have powered Linux machines for years. Basic operations of OS like process management, I/O management, memory management, and so on, are managed by the native stripped-down Linux kernel, using memory for each application. Memory for each application in Android is managed by its own runtime and virtual machine, which is little unusual. Android runtime also manages the process lifetimes and ensures application responsiveness by stopping and killing processes as necessary to free resources for higher priority applications. Every app runs in a separate process within its own Dalvik instance by giving responsibility for memory and process management to the Android runtime. Android runtime stops and kills processes which are necessary to manage resources. Dalvik and the Android runtime sit on top of a Linux kernel to handle low-level hardware interaction, while a set of APIs provides access to all of the underlying services, features, and hardware. The Dalvik virtual machine. It is defined as one of the crucial elements of Android. Rather using a traditional JVM, Java Virtual Machine, like Java ME, Java Mobile Edition, Android utilizes its own customized VM, virtual machine, designed to manage multiple instances on a single device. Following are some function of the Dalvik VM. It uses the Linux kernel to manage low-level functionalities like threading, process, security, and memory management. As middle tier, it is used for managing hardware and system service access of Android devices. It provides an abstraction layer to developers that ensure they never have to worry about a particular hardware implementation. It executes executable files, a compressed format, to ensure minimal use of memory. Application priorities and process states. The sequence in which processes are killed to reclaim resources is basically determined by priorities given to hosted applications. The priority of an application is equal to its highest priority component. The process that has a lower priority will be killed first. Priorities are also affected by inter-process dependencies. An app that has a dependency on another app will have at least as high a priority as the application it supports. All apps will remain running in memory until the Android needs its resources for other applications. Figure 5.13 gives details of states of the application states. Table 5.3 States of processes. Active processes. Processes are active if they are in the foreground. and responding to user events. Services which are executing an onStart, onCreate, or onDestroy. Event handler. Visible processes. Processes are visible if they aren't in the foreground, or responding to user events. When an activity is only partially obscured, like a non-full screen or transparent activity. Usually there are very few visible processes, and they'll only be killed in extreme conditions to support active processes to continue. Started processes. These are the services that should be continued without a visible interface, as services don't interact directly with the user. They get a slightly lower priority than visible processes. They are still kept in the category of foreground processes and won't be killed unless resources are required for active or visible processes. Background processes. Hosting processes which aren't visible and that don't have any services that have been started are considered background processes. Usually there will be a large number of background processes that will be killed using a last seen first killed pattern to reclaim resources for foreground processes. Empty processes. For improving system performance, Android usually holds apps in memory after they have attained the end of their lifetimes. It maintains this cache to improve the startup time of applications. These processes are regularly killed as needed. Android also oversees opened applications which are running in the background. IIT closes the applications when the system needs memory. However, most of the Android users are not fully satisfied with how it does its things because sometimes it keeps too many processes running, which reduces the system performance. We can use Task Manager, which does its job very well. I think now you might be clear with the concept of memory in Android. 5.5 Virtual reality. A computer technology that uses software programs for generating the realistic images, sounds, and other sensations are known as virtual realities. In other words, an imaginary environment which simulates user physical presence is termed as virtual reality. It has been characterized as a reasonable and immersive simulation of a 3D domain, set up utilizing intuitive programming and equipment. The made virtual condition can be experienced or controlled by the action of the body or as an immersive, intelligent affair created by a PC. A user having virtual reality gadget is normally ready to glance around the imitated world, move about in it, and connect with the environment. Things that are portrayed on a screen or in goggles. In today's world, virtual realities are depicted either on a computer monitor, a projector screen, or with a virtual reality headset, which is also known as head-mounted display or HMD. Now, advanced haptic capacity to grasp something systems include tactile information, i.e. sense of touch, usually known as force response in video, gaming, medical, and military training applications. Couple of virtual reality frameworks utilized as a part of computer games can transmit vibrations in different sensations to the user with the assistance of an amusement controller. Virtual nearness of users can likewise be accomplished through teleexistence. Telepresence, or the utilization of a virtual artifact, VA, the artificial condition, can be indistinguishable to the present world for making a genuine life experience. Recently, Google developed a virtual reality VR platform which is known by the name Daydream for Android Nougat, the 7th version of the Android mobile operating system. In May 2016, Google uncovered Daydream, a VR platform that works on its smartphone and furthermore gives VR abilities through a virtual reality headset and controller composed by Google itself. 5.6 Summary. Android is a robust operating system that supports a large number of apps in smartphones. These apps make life easier and advanced for the users. Hardware that supports Android is mainly based on ARM architecture platform, which is as follows: application framework, virtual machine, browser, graphics, database, SQLite, multimedia support, GSM, Bluetooth, Edge, 4G, 3G, Wi-Fi, GPS, camera, compass. Android mobile OS comes up with a pre-installed App Store which is commonly known as Google Play Store. It allows Android mobile users to select, and download applications developed by third-party developers and use them. There are around 2.8 million apps available on the market for users. Android apps are developed using Java. Android Mobile OS is available as open-source software for developers to develop apps. Android applications are made out of at least one application segments like activities, services, content suppliers, and broadcast receivers. Each segment has its own part to determine the general conduct of the application, and each one can be enacted individually, even by different applications. All components in the application must be declared by the manifest file, including declaration of all application requirements, like minimum version of Android and any hardware configurations. Thank you for watching. We will see you in the next video with the next chapter.